Welcome to Section 5, which is Properties of Logs. Today's video does not require a calculator, so you should not be using a calculator on today's video. We have two objectives. First, we are going to simplify and evaluate expressions using properties of logs. And then we're also going to solve equations using properties of logs. So everything today involves the properties of logs. These properties are extremely important. Your life will be made a lot easier if you can memorize the properties in today's video. If you do not, the rest of the chapter is going to be very difficult for you. So the first two properties that we're going to learn are the product and quotient properties. Product means multiply. So if you see in this example, it says log base x of a multiplied by b. So here's where our product comes in. That is equal to log base x of a add log base x of b. So if I have one log where the argument is being multiplied, I can split it up into two logs where I'm adding. And notice that my base stayed the same. My base was x, I have a base of x, I have a base of x. That's the product property. Now the quotient property, quotient is dividing. You're going to notice my argument, I have a divided by b. When I divide, instead of adding, it becomes log base a subtract log base x of b. Again, I have log base x, it stayed log base x, log base x. Okay, so all you have to remember is adding becomes addition, or multiplication becomes addition, division becomes subtraction. So let's see how we're actually going to use these properties. In example 1, it says log base 4 of 2 is 0.5, and I'm going to use that to approximate the value of log base 4 of 32. Okay, so I'm either going to be using the product or quotient property. I'm going to be multiplying or dividing. I need to think, how am I going to get from 2 to 32? So let's break down 32. 32 is 16 times 2. 16 is 4 times 4. 4 is 2, 2, 2, 2. So really, log base 4 of 32, that's the same thing as log base 4 of 2 times 2 times 2 times 2 times 2. 5 2's. Then I'm going to use the product property. So I have one log, 5 arguments being multiplied together, so I'm going to break it up. This becomes log base 4 of 2, add 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 log base 4 of 2. 5 of them. Now this looks pretty ugly. Why would I ever do this? It's getting longer. Well, I know that log base 4 of 2 is 0.5. So now this is really 0.5. Add 0.5. Add 0.5. Add 0.5. Add 0.5. Now 0.5 and 0.5 is 1. 0.5 and 0.5 is 1. And then I have 0.5 again. So 1, 1, 0.5 becomes 2.5. So log base 4 of 32 is just 2.5. Now initially this seems probably a little difficult. A lot of it comes with just intuition. You're going to be given some numbers and you're going to have to break them up. Sometimes you're going to know right away. Sometimes you're going to have to play around with the numbers a little bit. Like example 2, it says log base 4 of 3 is 0.7925. Log base 4 of 5 is 1.161. And we're approximating these two values. Okay, this time I'm going to be using the quotient property. So I have log base 4 of 12 divided by 5. This becomes log base 4 of 12 subtract log base 4 of 5. Okay, now I have to remember to keep the same base. So I have log base 4, so that's what comes down. Now, log base 4 of 5 I was given. Log base 4 of 12 I was not given though. So what do I just quit right here? No, you have to think. Can I break down 12 at all? Well, yes, I can. This becomes log base 4. 12 is 4 multiplied by 3. Okay, this is starting to look a little better. I'm going to use the product property on that. So it becomes log base 4 of 4, add log base 4 of 3, subtract log base 4 of 5. Now, I know log base 4 of 3, I know log base 4 of 5, I was given both of those. I don't know log base 4 of 4. So this is where a lot of students get stuck. So log base 4 of 4 is some number x. So I'm going to set it equal to x. Not really a big fan of logs, so I'm going to put this back in exponential form. This becomes 4 to the x equals 4. So base exponent argument. So this is 4 to the x equals 4 to the first, so x equals 1. So this expression log base 4 of 4, that's just equal to 1. Which leads us to an important point, which we'll write down later. So really, this becomes 1, add log base 4 of 3, which is 0.7925, subtract 1.161. So this is 1.7925. I'm going to move this a little bit. I'm subtracting 1.161. 5 subtract 0 is 5. 2 subtract 1 is 1. 9 subtract 6 is 3. 7 subtract 1 is 6. 1 subtract 1 is 0. So here's my answer. This whole expression just becomes 0.6315. Before I hear any complaints, yes, you'll be expected to do this without a calculator. So you might have to review some of those addition and subtraction rules. So what I wanted to point out is log base x of x is always equal to 1. So anytime the base and the argument match, the answer is 1. So that's why over here, base was 4, the argument was 4, the answer is 1. Okay. I would like you to take a few minutes, probably 2 or 3 minutes, and try this second example, the one with the stop sign. So pause the video and try this one on your own, please. You should be able to figure out how to do this. Good luck. Okay, let's see how we did. Using the quotient property, this becomes log base 4 of 25, subtract log base 4 of 16. Now I don't have either of those, so I'm going to have to break down 25 and 16. Now 25 is 5 times 5. 16 is 4 times 4. So this becomes log base 4 of 5. Add log base 4 of 5, subtract log base 4 of 4, add log base 4 of 4. Now log base 4 of 5 is 1.161, add 1.161, subtract log base 4 of 4 is 1, log base 4 of 4 is 1. Now I'm going to add this 1.161, 1.161. 1 add 1 is 2. 6 add 6 is 12. Remember to carry the 1. So this becomes 3, and then 2. So this is 2.322, subtract 2, which is 0.322. My guess is you probably made a mistake somewhere along the way, which is fine. Definitely okay to make mistakes. I actually expect you to make mistakes. Just going through again real quick what I did. 25 is 5 times 5. So this broke down into log base 4 of 5, add log base 4 of 5. 16 is 4 times 4. So that becomes log base 4 of 4, log base 4 of 4. What you need to remember is you're subtracting both of those. That's why I kept them in parentheses, so I remember to subtract them both. Log base 4 of 4 is 1. So I end up subtracting 2. Sometimes students get confused and they lose a negative somewhere along the way. But your final answer should have been 0.322. So those were the first two properties, the product and quotient properties. And we're going to have a lot of practice with those in class. Moving on, we're going to learn the power property. So that's right here. Sorry I didn't give you too much room. Log base b of m to the p equals p multiplied by log base b of m. So all the power property is saying is if you have an exponent, you can bring it out in front. So example 3, it says log base 2 of 5 is 2.3219. Approximate the value of log base 2 of 25. Well, I know that log base 2 of 25 is the same as log base 2 of 5 squared. And now by the power property, that exponent just comes out in front. This becomes 2 multiplied by log base 2 of 5. How does that help? Well, I know log base 2 of 5. So this really is 2 multiplied by 2.3219. So I'm going to have to do some multiplication. 2.3219 multiplied by 2. 9 multiplied by 2 is 18, and carry the 1. 1 multiplied by 2 is 2. Add that 1 becomes 3. 2 times 2 is 4. 3 times 2 is 6. 2 times 2 is 4. So this becomes my answer. My answer is 4.6438. Okay, I would like you to pause the video and try example 4 on your own, please. I give you log base 3 of 7, and I want you to find log base 3 of 147. Now, you may need a calculator to figure out how to break down 147. Good luck. Okay, let's see how we did. Sorry. 47 is 49 multiplied by 3. So log base 3 of 147, that's the same as log base 3 of 49 multiplied by 3. Using the product rule, this becomes log base 3 of 49, add log base 3 of 3. Now, 49 is 7 squared. Using the power property, I can now bring that 2 out in front. So this becomes 2 log base 3 of 7, add log base 3 of 3. Now, log base 3 of 7, we already know from the problem, so this becomes 2 multiplied by 1.7712, add. Now, remember I told you, anytime the base is the same as the argument, the answer is 1. So log base 3 of 3 is just 1. Okay, so I have 1.7712 that I need to multiply by 2. 2 multiplied by 2 is 4. 2 multiplied by 1 is 2. 2 multiplied by 7 is 14, and I carry the 1. 2 multiplied by 7 is 14. Add 1 becomes 15. Carry the 1. 2 multiplied by 1 is 2. Add 1 is 3. So I have 3.5424. Add 1. So this becomes 4.5424. Remember that 1 comes from back here. So log base 3 of 147 is 4.5424. Okay, so that was the first 4 examples. We have 3 more examples on the next page, all involving the same properties. They are going to look a little different though, so if you would please flip the page. Looking at example number 5, it says solve, and then it gives you an equation. The first thing that we're going to notice is that we have a log on the left side of the equation, but no logs on the right side. Next thing I want you to notice is I have log base 6 and log base 6. Okay, so I have 2 logs with the same base. I want to combine them into 1 log. Now, 2 logs, and I'm adding, become 1 log when I multiply. So this becomes log base 6 of x times x minus 9 equals 2. So I took two logs and condensed them into one. Because I was adding the logs, the arguments get multiplied. If I multiply that x by the x minus 9, this becomes log base 6 of x squared minus 9x. Okay, at this point, it's really tempting to set x squared minus 9x equal to 2. We did that in the last section. You can't do that, though, because I have a log on the left side, but no log on the right side of the equation. So I can't set anything equal yet. Instead, what I'm going to do is I'm going to rewrite this in exponential form instead of logarithmic form. Remember, 6 is the base, 2 is the exponent, so this becomes 6 squared equals my argument, x squared minus 9x. Continuing this, 6 squared is 36, so I get 36 equals x squared minus 9x. Subtracting 36, I get 0 equals x squared minus 9x minus 36. Okay, I'm back to a quadratic. From the last section in the last video, I should remember the ways to solve a quadratic are factoring, quadratic formula, square root method. I always like to start out with factoring. Not every quadratic will factor, but it's a good place to start. I'm looking for two numbers that multiply to negative 36, but add to be negative 9. Okay, so multiply to negative 36 and add to be negative 9. Hopefully you know that's x minus 12, x add 3. So negative 12 multiplied by 3 is negative 36. Negative 12 add 3 is negative 9. Now set both equal to 0, so I have x minus 12 equals 0, x plus 3 equals 0. This gives me x equals 12 and negative 3. Now I need to look, is it possible to use both of those numbers in my logs? If I substitute in 12, I get log base 6 of 12, and I get log base 6 of 3. Those are both good. If I substitute in negative 3, I get log base 6 of negative 3, and log base 6 of negative 12. I can't take logs of a negative number, so that negative 3 is not going to work. My only answer is x equals 12. Okay, let's look at example 6. It says solve, and then it gives us an equation. So first thing we're going to notice is we have 3 different logs. Every number is connected to a log. I have 2 logs on the right side. So what I want to do is condense those into one log. I can do that because they both have the same base. Log base 7, log base 7. Like the last problem, if I'm adding logs, when I convert them to one log, the arguments get multiplied. So it becomes 27 multiplied by 3. Okay, so 27 multiplied by 3 is 81. So on the right side, I really have log base 7 of 81. So what I did is I took 2 logs that we're adding, I combined them into one. Because of the product property, when I'm adding logs, that's the same as multiplying the arguments. Now, on the left side, I have 2 log base 7 of x. Remember that 2 is a power, becomes an exponent on the x. So really, that's log base 7 of x squared. Now you're probably asking, why would I do that? Why would I make the 2 a power? Well, what's really nice now is I have log base 7, log base 7. So I can set the arguments equal. So I really have x squared equals 81. Same base, same log, I can set the arguments equal. Taking the square root, you get x equals plus or minus 9. Remember, you always get positive and a negative. Now looking back at my equation, I have log base 7 of x. So I have log base 7 of 9, that's good. Log base 7 of negative 9, not so good. We don't take logs of negative numbers. So your only answer is the positive 9. X equals positive 9. Now, this last example is for you to do on your own. Pause the video and try this one on your own. It's very similar to example number 5. So look back at example 5 if you need any help. Good luck. Okay, let's see how we did. You should have gotten x equals -8 and +2. -8 does not work in your problem, so your final answer should have been x equals 2. If you did not get that, you need to go back and fix your mistakes. When you come to class tomorrow, we will be checking to see that you have the problem completed with all of the work. If you have any questions, please bring them to class. Good luck.